Hello and welcome to this beginner tutorial on actual modelling. We are going to design this sci-fi hallway / corridor that you can see on your screen. So what we're going to do is start the episode with all of the different modelling techniques, and then later in the episode we're going to apply those techniques that we learn and make this sci-fi corridor. So let's not waste any more time and jump right into it. In this video, I will use a fair amount of shortcuts. I will try and call them out as and when I do. If I don't, I've got my screencast keys in the bottom left corner here. So left click, middle click, right click. Then obviously we've got the G, Z, S, anything that might happen. So we've even got delete and it will say what I do there. So now that's out of the way, let's look at fill. We covered fill in episode 1, but we can always reiterate over it here. So what we do is we select 2 edges and then press F to make a face, or we can select 4 vertices and then we can select and make a face that way. So to select vertices we press 1, for edges it's 2, and for face it's 3. So 1, 2 and 3, like so. If we give Blender enough information, we can get away with just highlighting the one edge and then it will make the loop as it goes around. So deleting this by pressing X, if we bring in a torus, what we can do is if we hold Alt to select all these faces in a loop and then press X and delete only the faces, if we now only select one edge and press F, we'll see that nothing happens. So if we tell it what face to make by connecting these 2 edges together and then select only the one and hold F, it will go all the way around and then eventually bridge all the gaps. Next up we have loop cut, and these add evenly spaced edge loops to control shape and support subdivisions. So the shortcut for this is Ctrl R, and then what we can do is if we go to our nearest edge it will select where we make this loop cut. And before we click to confirm that we want this, we can use the scroll wheel to select if we want more or less, and then once we do click we can actually slide them to where we want them. So we can either click to basically say we want them here like so, or we can just right click and then that will just put them back in the center and keep them there. Inset Faces creates smaller faces within a face for panel recesses or borders, for example. So with our face mode selected, if we select this face up here and press I, we'll start to inset like this, and then we can use Control on top of to either raise or lower set face. If we don't want that, then what we have to do is we just have to inset without pressing Control at all. Another thing about inset is if we bring in a plane and then we do a loop cut there and a loop cut there, we now have 4 faces, and if we press I, we'll be insetting all of the selection, but if we press I again, we'll now inset on individual faces like so. So one other thing that we need to keep into account when using inset is if we have an object that isn't scaled properly. So I'm going to use these 2 rectangles here, one is scaled and one isn't. We'll see that the one on the left, this one, will have a bigger border on one side as opposed to the one on the right, which has even borders all around. So as we can see with this one, this is a lot thicker than here, and that's because this isn't scaled. So always keep that in mind. Poke Faces adds a central vertex and then connects it to the corners, and then this will form triangles. So just like our Inset Faces, if we have face selection selected and then we go up to our face tab here and click Poke Faces, we'll see that we're given our central vertex and then triangles all around. Interestingly, this also works on n-gons, so if we do a loop cut here and there and then shift select the inner edges, delete them, and then using edge selection, if we just do a loop select and then fill and then select the other vertices and then spread them out everywhere but the Z, and then what we can do is with our face selection we can go face and then poke faces, and then we've got our central vertex with all of our triangles. Extruding is a tool that you'll probably use 90% of the time, and it creates new geometry by basically extending vertices, edges or faces. So starting with vertices, if we press E to extrude, we basically just create new geometry like that, and we can then do it on edges as well, and we can also do it on faces like so. With our face selection, we also have 3 extra options. So if we press Alt E, we can extrude faces along normals like so, and we can use Shift to be more precise, we can use S for even thickness, and we can use Alt to basically invert our S selection. On top of that, we can also extrude individual faces, which gives us this power, and then we also have extrude manifold. So if we extrude normally, you'll see that we get this issue here, whereas if we use Alt E and extrude manifold, you'll see that we don't necessarily get the issue that's called Z fighting, which is where we get 2 planes that basically argue with each other. And if you want to basically inset, you can also extrude inwards without actually breaking your geometry like we did with this example just. In Blender, we can press G to move, and then that moves us freely on the X, Y and Z. And if we press X, it locks us on the X, Y locks us on the Y, and Z locks us on the Z. That's the same with rotate on the X, Y and Z, along with scaling on the X, Y and Z. So if you hear me in this video or any future ones say everything but the and then axis, what I'm doing is if we move and then do Shift X, we are now locked on the Y and Z position, as you can see here, and it's not limited to just the X, we can do everything but the Y and everything but the Z. This applies to scale as well, so if we do Shift X for scale, we'll only scale on the Y and Z. Shift Y will X and Z, and then Shift Z is X and Y. Rotate doesn't seem to be affected. If we rotate on just the X or Shift X, we only ever seem to rotate on the X. Not sure if that's a bug or what's meant to happen. But yeah, so basically if you hear me say anything but the, I'm typically pressing Shift that axis. So a way to think of it is Shift and the axis means nothing on that axis, unless it's rotate, because again, for some reason, that one is unaffected. The knife tool can be used to create custom shapes by cutting into the geometry itself. So going into edit mode, if we press K, that will bring us our knife tool, and it will snap to our vertices. We can use Shift to snap into the middle of the edge, but other than that, we can basically just cut along the sides like this, and then we've now got our new shape. And then what we can do, for example, is we could extrude this face up, and now we have this shape. So basically, yeah, the knife tool just cuts geometry. Duplicate linked is great for creating copies that share data, and it's perfect for modular assets. So there's 2 ways we can do this. We can either use Shift D and then grab our copy over and click linked there. And then what we can do is we can go into edit mode, and any changes we do on this model affects this one, and any changes we do on this model affects that one. Another way that we can do this is if we just delete this one, we can do Alt D, and Alt D basically just makes sure they're linked to begin with, as opposed to you having to say, yes, I want it to be linked. Shift R just repeats your previous action, and it speeds up repetitive tasks. So if I was to move this on the Y, like so, and it's 2.4207, and I press Shift R, we'll now see it's at 4.8. And it's not just used for basically moving cubes, we can also just shrink it down like so. We can Shift D, and then we can move it like so, and then Shift R, Shift R, Shift R, and now we've made our own stairway like so. So Shift R repeats last action. Selection is going to be a 3-in-1 tip, and to better visualize this, I'm going to bring in a UV sphere. So with a vertex selected, so we're going to pick this top one. If you do Control and then number pad plus, you'll find that you basically select the adjacent vertices, Control number pad minus will start to receive that selection, and it's not just vertices, we can do it with edges as well, and even faces. And then Control L will just select everything that's linked to this one object. So if we had another sphere, basically, and then we select this one, we don't select anything to do with the other one because they are independent of each other. So if we were to select that and then select this one, and then we just bring them closer together so that we can merge their end vertices, like so. And then what we can do now is if we do Control L for this, we'll select everything because everything is linked. Control J joins selected objects and makes them into one. So say for example we had a circle here and then we have a cube as well, and then we're just going to make this really narrow and then really flat and then bring it in on the X like so. And say this was a sundial by some extent. Instead of exporting, say, the face and then what would be used to cast a shadow, instead what we can do is select these, press Ctrl J, and now it is our sundial. So Ctrl J basically just gathers everything and then turns it into one object, and they are still independent even in edit mode, so we can move the thing that casts a shadow and then we can move the face accordingly. If you find that you've modelled quite a bit and then you basically have a big long list of items here, then what you can do is you can actually just use M as opposed to edit mode where M is your merge. If we're in object mode, then what M does is we can move to a collection and we can either search for one or make a new one, and I'm just going to call this collection cubes. So now we can have our cube in our cubes. You can even drag and drop like so. And then what we can do is we can use this to hide our cubes, and now we can see our curves and our planes. Merge combines vertices or edges to clean up topology. So to showcase this, if we bring in a plane and then Shift D and move it on the Y, and then if we do the same but on the X, and then we'll just snap it so all the vertices are guaranteed to be over each other, then select each individual plane and then press Ctrl J to turn it into one object. One of the issues that we have is if we move this edge, we don't also move this edge. Just like if we move this vertex here, we don't move the other two that are overlapping each other there. So we've got a few options when it comes to merging. We will select everything and we can either merge at center and then that will merge everything to the center. We have merge at cursor and then that will just merge everything that's selected to the 3D cursor. We have collapse, and what that does is, as you see, we've got 3 individual planes. So this will then merge all the vertices and position them at the average center. So if we do collapse here, we'll see that we've got these 3 points. Whereas if we were to subdivide one of them and then heavily move it all the way over here and then basically add a load of extra loop cuts, now if we select everything and then collapse, we'll see that this one is now more over here and it's not on our same axis line as this one. But the one that we'll probably be after a lot of the time is highlighting everything, pressing M and merging by distance. And now what we've got is this one vertex now moves and affects all 3 individual planes, and these planes are now no longer independent of each other, because now if we do collapse, we'll see that it collapses everything because they are now all one actual object. Separate geometry into new objects. So for example, if we have this cube here and another one here, we can find that this is all one object, and then if we did P, we can do separate selection. So now this is its own cube and then these 2 are still together. So if we join them back up again, we can also highlight everything and then separate by loose parts. So now we have 3 individual cubes. And one other thing is we can also separate by material. And the way that this works is over here we have our material options. So if we just highlight everything and then apply material 1 to them, and then we'll just select these two on the end, and then we'll basically bring in another material, and that will be our material 2. So we're going to assign that, and then the top is also going to be material 2 of our middle one, and then the sides are going to be material 1 of our ones that are either side. So now if we select everything and do P and separate by material, we'll see that our center cube is missing its top but has these two sides, and the ones on the sides have the top of the middle cube. Bevel Edges is used to round or chamfer edges. So if we go into edit mode and select just these top edges here and do Control B, we'll see that we get this nice rounded off effect, and we can use the scroll wheel to either increase or decrease the number of edge loops that basically happen. So as you can see, we've got this chamfer, but then if we wanted to round it off, we can basically just introduce more loops, like so. And then what we can do is using Alt, we can select this one and this one for example, and then same again, just do Control B, and now we've got this chocolate shape, I guess. These aren't the only thing that can be beveled. You can also bevel vertices or vertex by doing Control, Shift and B. You can then use the scroll wheel to decide how many cuts you want to make, and then this will just give us a rounded edge. This is useful for if you want to make holes in individual faces. So for example, if we do a loop cut here and a loop cut here, with just the one on its own, if you do Control Shift B, you can get a star shape and then eventually a square shape with the minimum. But what I tend to do if I want to make circles is I'll use the knife tool to cut directly across the middle like so, and then exactly do the exact same, and then select the vertex in the middle, Control Shift B, and then you can now get a circle. Subdivisions add resolution to your objects by splitting the faces evenly. So you can do right click and then subdivide, and now each face is made up of 4 or 9, and it gets exponentially more as you increase the number of cuts. And that is basically that one. The Vertex Bevel Crease is handy because if, for example, you have a plane and you loop cut it top to bottom and then left to right, and then you come over and add a subdivision modifier like so, and then make it a couple of levels, we have these rounded corners. So okay, let's also come in here and vertex bevel as well, and then we'll cut a hole in there. So we've got this nice circle, but we don't want the edges also coming out. What we can do is we can either select these vertices, even the ones on the side, and then come over to our mean vertex crease, and then we can increase it like so, and then it'll turn purple to represent that we've been creased. Or we can highlight the edges, for example, like so, and then what we can do is we can do a mean crease with the edges instead, and then the edges are now purple. So now we've got our circular middle, but we've got our sharpened edge. Triangulation converts faces into triangles for game-ready geometry or export consistency. So this one is just a matter of going to face and then triangulate faces, and it will turn everything into a triangle. You can even do this with n-gons, however it can look messy. So as you can see here, we've got one face with 32 vertices, and if we go to face and then triangulate faces, we'll see that some triangles are definitely bigger than others. So try and keep 2 polygons or triangles during your workflow, but worst case scenario, you can still triangulate with n-gons. Just like how you can turn things into triangles, you can also turn them back into quads if your geometry basically allows. So again, we can go up to face, and then we can do triangles to quads, and our cube has now come back to being our cube. However, if we applied this to our circle that we made earlier, we won't get as much of a nice result, and that is because we get the one quad. So again, preferably don't work with n-gons if you can get away with it. Checker Deselect is great for selecting alternating faces, edges or vertices. So what we can do here is if we just remove this cube and bring in a circle, for example, if we look at all the vertices and come up to Select and Checker Deselect, we'll find that we now have every other vertex. The same can be applied for edges, so if we go to Select and then Checker Deselect, we'll have all the other edges, so we can extrude edges, say, and then scale outwards or inwards. And then lastly, we've also got faces. So if we bring in a plane and then we Shift D and move on to Y2 and then Shift R quite a few times. Then if we select all and merge by distance and then make sure we've got our line of faces selected, if we do Select and then Checker Deselect, we now have every other face. So now we can do any form of editing that we need to do. Edge split allows us to separate edges to control shading or hard surface breaks. So for example, we can put a loop cut here, here and here, and then select all of these, right click and go to where it says edge split. So now we can select everything to do with this one and this one, or we can press A and then P to separate by loose parts, and now we have all of these as their own separate objects or meshes. Edge slide allows us to move edges along adjacent surfaces without actually distorting shape. So for example, if we brought in a loop cut here and then we wanted it to sort of be close to this side, if we press G, we'll distort the shape, but if we press G again, we'll start to move along the edge like so. And as you can see, we haven't actually distorted the shape in any way, shape or form. So now we have this diagonal cut basically across our face, and again the shape isn't deformed. The spin tool is great for rotating geometry around a pivot to form circular shapes like pipes or arches. So what you need to make sure of is if you do Shift S and bring the cursor to selected, because in my experience the spin tool works based around the cursor. So if we go into face selection on this cube and then select X because we want to go across the X axis, we can then basically drag this and then we can use this to have finer control, so 45 degrees. We don't want it to do 12 steps, we want it to do 3 say, and then basically that's all we need. And then we can basically inset, for example, maybe extrude again, and then if we bring Shift S cursor to selected, we can bring this out a little bit more, and then now we've got a ventilation system, for example. Another good thing that it can be used for is pipes. So if we have a cylinder and then we just extrude it up like that, so it's more pipe, I suppose, and then if we select this vertex here, Shift S, cursor to selected, select the face, and then this time we want to move it on the Y, and now we can basically bring our pipe around. We want it to be 90 degrees, and then because it does look fairly cut up, we can then increase our steps to make it look a lot smoother. Mark Sharp forces crisp shading along selected edges. So for example, if I beveled this edge right here, inset the face and then extruded in and then shaded smooth, we'll see that we have this horrible look. So I'm just going to duplicate this so we have a reference, but if we then select all around this outside part and this one, and then select these along with down here, all across the back, for example, and this is an extreme scenario. If we then right click and then click Mark Sharp, we'll see that we now have nicer, cleaner shading, as opposed to this one where the shading doesn't look all that nice. what I'm going to show you now are some visual aids that you can use that primarily will hopefully help you see what's wrong with your geometry if anything was to go wrong. So the first one is having face orientation. So like before, if we did our Alt-E for extrude and then extruded manifold and went back on ourselves, our whole mesh turns red. And that's because the normals are now inside. So what we can do is Shift N to recalculate them, and now they're facing outside where we should be, and that is all thanks to seeing it with our face orientation. The next one is smooth faces. So if we had a UV sphere, for example, we can see all of the individual polygons that make up our UV sphere. But if we right click and shade auto smooth or even shade smooth, it will now look smooth basically. It does what it says on the tin. Cavity, that is another one. So if you were to look at this cube from this angle, you will see that these two look approximately close to being the same shade of grey. So if we come over to our viewport shading tab and turn on cavity down here, this just enhances our viewport contrast and it just reveals surface depth and detail. Another one is wireframe. So this allows us to see our geometry without having to actually go into edit mode. So for example, if we did say 4 loop cuts here, we can see that all the way in object mode as well, without having to basically try and go into edit mode and see if we can visualize it that way. And then one last one is the X-ray mode, and what that does is it allows us to see faces. So for example, we can see these dots that showcase these, and if we extrude this up, we'll see that we're fine. But sometimes, in my experience, I'll have a face that's in the middle here. And one example of doing that is if I was to use the mirror modifier, which I'll show you in a little bit. But basically what we've got here is we've got a face, and then if we go back into our regular shading here and then turn on shade smooth, we'll see that we get this sort of kink. So if we were to delete that face, our shading becomes a little bit better. So yeah, basically use the X-ray, wireframe, cavity, smooth the faces, and try and look for your face orientation, and then it will save you any issues that you might suffer from later. Modifiers are great for the 3D modeling process because it means we can adjust our geometry without committing to the process. So one of the ones that I commonly use is the Subdivision surface, which is this one here. And as you can see, you'd think that it's turned our cube into a sphere, but we can basically turn it off and bring it back on again. And then this one basically says if it's visible in edit mode or not. So for example, this is what our cube looks like. That's the sphere with our subdivision surface, and if we wanted to, we could add a loop cut to support towards the top, or we could even just bevel these edges, and then basically that'll make our top look a lot flatter like so. So now we're heading towards a drum shape, for example. Another one is the mirror modifier, and this one works based on the origin. So if I move this over on the X by 1 meter, as it's a 2 meter cube, and then generate and come to mirror, it just means that anything we do over here will basically get mirrored exactly the same on the other side, like so. So now we've got this. And like I was saying earlier, if we now look at this, so we also have a merge and a clipping here, but what I was getting at earlier is if we were to apply this, we'll find that we've got a face in the middle, like so. So this can catch you out, so just be careful of it. Solidify is another modifier, and that one is really good for basically turning 2D shapes into 3D. So if, for example, I made this here, and then I wanted to basically just move that down a bit like so. So we have this 2D shape, there's nothing 3D about it. So if we go to Modifier and Generate, and then come over to Solidify, we can adjust the thickness, and now it basically has become a 3D shape. Another one is the bevel modifier. So basically, if you don't want to commit to a bevel, you can come to Modifier, Generate, and then Bevel. You can increase the number of segments, and you can increase the size or decrease the size accordingly so you don't have those razor sharp edges. And then basically if you find that no, I don't want these anymore, you can either turn them off, or you could even throw a subdivision on top of. So instead of your cube becoming a almost sphere straight away, you can instead bevel the edges and then subdivide afterwards. Weld is another tool or modifier that you can use, and it basically is merge again without the commitment. So if we were to duplicate this cube and move it on the X like so, and then bridge it together like this, we'll see that we have 16 vertices. But if we come to add modifier and then generate and weld, we'll see that it now drops down to 12. But the only thing that you'll have to remember about this one is if you do move a vertex in edit mode, it doesn't actually move the other one with it as well. Another modifier that I tend to use is the array modifier. So if we were to bring in a plane and then we just shrink it by the X, just like so, and then what we can do is apply our scale. If we go to generate and array, what we'll get is the number of these items that we want. So array basically duplicates the object and it just gives you a lot of them immediately. So our offset is basically how much do we want it to be offset by. 1 basically means the exact size of the object. So if I was to apply a subdivision here and then move that along the X just to visualize this, and now we have our chevrons, for example, this vertex here is basically going to be right in line with this, and if it was still the plane, then it just means the first vertex will basically be sitting on the last vertex of this one. So these tend to get coupled up with it used to be a curve modifier, which was a deform, but we can just use curve with this. And if we input a curve and make a path, and then we select this and then just drag that and then extrude it a bit over here and extrude it a bit over there, and we have this wiggly line. So now if we go to our plane and select this path, we will have it basically following this path. And if you don't want to align the rotation, you can just have it like this if you want them to be facing the X direction, say. But if you want them to follow basically the path that the path is going down, align rotation, and then what you'll have to do is with edit mode, you can then just basically go into rotate on the X, and then you can rotate on the X 90 degrees, and then hopefully it will start to follow the X or the direction of the path like so. So there you go, and then if we have it come back on itself, and basically this is handy for if you were making a racetrack, for example, if you wanted to have, say, cones on the sidelines. But yeah, basically this is another one of those modifiers that you tend to have, and then once you have all of these, so for example we can stack this with a solidify, and we'll do the solidify first and then just increase the thickness like so. And when you're happy with all these, you can then just go apply and apply again, and now we can delete the path, for example, and we've got all of these. And then, like we said before, we could move this, for instance, into a new collection, and we'll just call this our chevrons. And then we can P and then separate by loose parts, and now we can control each individual one. So this one could be removed because too much paint wear or it's been chipped away. One other thing that you will have to do is object, set origin, and then origin to geometry. So now if you rotate it on the Z, you rotate it there, as opposed to rotating on the Z and then it's at the 3D cursor, because it's where its origin point is, it's down here. So hopefully you've learned something. I know I have, and thank you for watching. I will see you in the next one.